Hi students, welcome to Alpha's e-learning program mathematics class. We are in trigonometry, the last concept, that is extreme values. Actually extreme values we used to discuss even in the other chapters also, but now particularly we are discussing about trigonometric functions. In trigonometric functions, extreme values, it is a very important topic with respect to JEE mains level as well as advanced level. So students, this topic actually covers whatever topics till now we have discussed, from trigonometric ratios and identities to till here, that is periodicity as well as transformations also. Okay, now let us come to here only trigonometric functions. Now we are going to discuss in this particular topic. Later in the chapter of functions or differential calculus, we discuss about the other functions also. Okay, now suppose you take here two real numbers a and b, right? Two real numbers a and b. Suppose x is in between a comma b. Now whenever x is in between a comma b means, don't understand, these are only integer values. Real number means here a value, b value, that means here suppose x value is lying between 2 comma this is 3, right? Suppose if I am giving in this way, the meaning is here x values in between 2 and 3 means it is nothing but 2.0001 etc. here 2.99999, like that it can take. That means here infinite number of real numbers exist, that simply we can denote as in this interval which is known as open interval, right? So this interval is known as here open interval. And now here you observe the values, that means x is taking all the values between a and b but except a and b, right? And next suppose if you consider this kind of interval, that is the difference between this and this is nothing but only equality symbol. Now here it is taking both a and b also, that means suppose if I write 2 less than or equal to x less than or equal to 3, the meaning is it is taking 2 as well as 2.001, 2.03 is 2 point etc. up to here 2.99999 etc. the last value 3 also it will take. So this kind of interval is known as here closed interval. So sometimes the representation may be like this or it may be in this way also. Now this is closed interval, the meaning is you are taking here both a and b also, and open interval excluding a and b, all other values which are in between a and b. So that is the only difference, and here these intervals maximum we represent terms with intervals, right? So this is closed and this one is open. And next one, suppose a value on real line, understand, suppose a value is greater than or equal to k, that means f of x is taking greater than or equal to k for all x belonging to some domain, understand, not the maybe the total domain, it may be here some particular interval or some values of x, or maybe here total domain also. And you know very well students, that is sin x, suppose if I take, it is greater than or equal to -1, understand, because you know here range of sin is nothing but -1 to here +1. So sin x greater than or equal to -1, suppose if you indicate here x values, actually we can say for all x belonging to R, isn't it? For every real number we have observed from graphs, and this one is greater than or equal to -1 means it is true for every real number. Now this is known as here, that means how the values are, it is above -1 including -1, here all other values are coming, right? Therefore this is known as minimum value. So whenever any function is greater than or equal to k means this k is known as minimum of that particular function for all x, wherever it is following, for all x belonging to that particular interval or domain, right? And suppose it is taking less than or equal to, understand, all values of f of x, these are all less than or equal to L. That means suppose if I am taking sin x value is less than or equal to 1, understand, whenever it is coming in this way, the meaning is what here, all values they are not going above 1. The extreme point is here how much? +1. So all values they are coming less than this one. then this one is known as here maximum value of this particular interval, particular function. For every x belonging to here we can say domain, that is all the real numbers. Therefore students, whenever you got this kind of inequality, f of x is greater than or equal to k, the meaning is you are taking here minimum value of f of x. And if it is less than or equal to, that means all our values are coming less than this. The meaning is it is the last value, that means maximum value. Whether it is minimum value or it is maximum value, the name is nothing but extreme. Extremely minimum or extremely high. So these are known as here extreme values, whether it is minimum or maximum. Now students, suppose a function is taking minimum is a k and maximum of the function is L. This is minimum value and this is maximum value. Then we define as range of that function is nothing but closed interval k comma L. Always minimum value, maximum value. That means you can say it is closed interval minimum maximum. Whenever you are writing, the interval must be here closed interval. If equality is not there, you cannot say it is a minimum value. For minimum value or maximum value, this equality must. That means if I write k less than f of x less than L, then I cannot say this is the minimum value, because if you write suppose 2 less than f of x less than some 5.1, right, and then the minimum you cannot say, because 2 is less than means what is the meaning here? 2 is coming here, 5.1 is coming here. Now the values you are getting in this way. Then the least you don't know exactly what is the particular value, 2.0000000. We can't say. At the same time you can't say it is 1.999999 like that, we can't say. That's why here whenever it is strictly less than, this is known as strictly less than symbol is given, then you cannot say this is the minimum value, this is the maximum value. Minimum, maximum, the word you can use only when here equality is specified. So equality is there, then only we call it as minimum or maximum. Whereas to define range, it can be open interval or closed interval. But as long as it is closed interval, surely you can say k is minimum and L is maximum. Suppose if I take here that same function, range of f of x is nothing but here open interval k comma L. So this also range you can define, but here you cannot say k is minimum value and L is here maximum value. Understand students? Now basing on these, actually we want to give exactly for all trigonometric functions the same kind of concepts we are going to discuss now, right? Now students, observe here, let us take our known trigonometric functions. Now minus 1 less than or equal to sin x less than or equal to 1. We know this is for all x belonging to its domain, that is all the real numbers. Therefore we wrote actually this is nothing but here sin x belonging to how much here? This is minus 1 comma 1 closed interval, right? Because equality symbol is there, and this is known as minimum value of sin x and this is known as maximum value of sin x. In the same way cos x also we follow. Then what about here secant? If at all I want to write as an interval, you know here secant x values, these are less than or equal to minus 1, or it is here secant x value greater than or equal to how much? Plus 1, right? So whenever it is coming in this way, then we write the interval form as all secant values. How are they here? They are less than or equal to minus 1. That means they are like this. Or it is not and. You have to here differentiate between or and every time very carefully. So this one is here 1, right? So in this way the values are coming. So secant x values less than or equal to minus 1, or all secant x values are above 1. Understand students? Then how we write as an interval like this? Then it is nothing but secant x value. It is not x value. It is total secant function. Secant x value belonging to here minus infinity comma minus 1. because it is going towards this side, means no other limit up to here minus infinity. So it is minus infinity minus 1 union. Whenever or is there, we represent it as union. It is again 1 comma here infinity, right? So in this way we represent secant x value. So what is here? Either minimum value exists here or maximum value exists, but both cannot happen here simultaneously. Moreover, minus infinity, you cannot say the least value because open interval, and none of us know about what is the extreme value, that is the least extreme value, we don't know. At the same time, you can't say here this is the maximum value infinity, because what is the reason? We don't know about what is particularly that value. Understand? That's why whenever minus infinity, infinity are coming here, don't call them as least value or greatest values, right? And now for this function secant dx, it is minus infinity minus 1, means either maximum value exists or this is here or minimum value exists, right students? So here this is less than or equal to 1 or secant x value greater than or equal to 1. Same tendency you can apply even for cosecant also. Cosecant x also here basing on the same result here. Of course domains are different, whereas here range is the same for cosecant dx. Understand students? Now what about here? Whenever I have taken the tan function, tan function actually the range is all the real numbers. That means it is belonging to open interval minus infinity comma infinity, or you can write it as simply tan x belonging to here all the real numbers. The same thing even you can use for cot also, all the real numbers. So interval wise, if at all I want to represent, this is the value. Now students observe here, in this particular interval again I cannot define about minimum value or maximum value. Understand? Because of the nature of minus infinity and infinity. Therefore suppose if you give some particular domain values, that means if I give minus pi by 4 to pi by 4, then we can say here the least value as well as greatest value. Okay, let us observe here one by one few kinds of functions. Now suppose students sin x value as it is falling between minus 1 and plus 1, then what about here sin square x? Okay, sin square x, square of that particular value. Now here it is in between minus 1 and 1, therefore sin square x being even power here, it will be always in between what here 0 to 1 for all x belonging to R, right? So this is one of the important condition. In the same way you can write even for tan also, tan, cos, etc. Now here tan value you can't write because it is up to infinity you can say. So for cos we can write in the same way, that is 0 less than or equal to cos square x less than or equal to 1 for all x belongs to R. Understand students? So therefore basing on this actually we can find now some kinds of minimum and maximum functions. Let us observe here students the value. Suppose if I give 3 minus 4 sin square x. Now I want here the minimum value of this function. Now before you find minimum value every time, just to have a little bit attention on domain. And here sin means the domain is nothing but all the real numbers. So 3 minus 4 sin square x. Whenever I am using, let us take this one as here f of x. The simple trick you can follow students, very easy, just basing on here the range of this sin square x. What is range of sin square x? It is from 0 to 1. Now some problems actually to solve here, we use here the range of known functions. What is the known function here? Sin square x is the known function. So using the range of this known function, you can find the range of total function. Understand? So you have to observe immediately any function is given, whether we know about range of one of those particular values or not. Let us observe here, you know clearly 0 less than or equal to sin square x value less than or equal to 1. I just want to make use of this one. Now let's multiply here minus 4. That means this is our known inequality for all x belongs to R. and now this inequality you are going to change exactly in this form, right? Now to change in this form, what is before sin square x here? Minus 4. Therefore let us multiply now here minus 4. Of course students, all of you aware of this inequality. If you multiply by minus symbol, inequality changes, because you know here 3 is less than 5, 100% sure, right? And suppose if I multiply minus 3, this is minus 5. What's happening here? This one is here 3 and this is 5, whereas here if you come across, it is minus 3 value, and here you got how much? Minus 5 value, right? Now here minus 3 is more than minus 5, as it is coming this side, real line, that is our x-axis. Therefore whenever 3 less than 5, if you just multiply by minus sign, inequality changes greater. So whenever quantities, whether they are negative or positive, but if you multiply by the opposite sign, immediately inequality changes. Therefore here minus 4 is there, hence if I multiply by minus 4, what will happen here? It is 0 greater than or equal to minus 4 sin square x greater than or equal to how much? Minus 4. Understand? Now I am just reversing the inequality. Understand? That is minus 4 less than or equal to minus 4 sin square x, and this is less than or equal to how much? 0. Got it? And now let's add here 3. Therefore 3 minus 4 less than or equal to 3 minus 4 sin square x less than or equal to, this is 3. Got it students? Now what about this value here? So we added here 3. This is becoming as here minus 1 less than or equal to 3 minus 4 sin square x, and this is less than or equal to 3. So what is our known inequality here? In this problem, sin square x you know about, it is in between 0 and 1. Then we want to make use of this result and convert in this form. To that purpose, just multiply by minus 4. So I multiplied by minus 4. Immediately inequality you have to change, because you are multiplying by opposite sign, and thereby if you reverse, it is minus 4 to again 0, and after that we want here 3 minus, therefore we added 3, that is 3 minus 4, 3 minus again here 3, and now this is here minus 1 and this one here 3. Therefore students, what is range of this function? The range is nothing but here how much? It is closed interval minus 1 comma 3. Understand? So what is the least value? The minimum value is minus 1 and the greatest value is plus 3. So these problems actually I wrote many steps, but you have to reduce here number of steps. Understand students? Now in the same way, suppose in a question they asked you about here our known functions, very important these are, that is sin square x and plus cos to the power of 4x. Right? What about here? Range. And next value sin to the power of 4x plus cos to the power of 4x. And next one is sin to the power of 6x plus cos to the power of 6x. In this way, suppose if they ask you about problems, what to do? Students, you know very well from multiple and submultiple angles, actually we derived some of these values, that is sin square x plus cos power 4x. What is this answer actually? It is 1 minus sin square x into cos square x, right? This is our value. And if you simplified, what is the simplified value you got? It is nothing but 1 minus, it is 1 by 4 times how much it is? Sin square 2x, right? So this is the formula which we derived from multiple and submultiple. So that's why here those kind of formula are very important, and if you use like this suddenly, that means you can remember very well. And what about here the formula? It is 1 minus 1 by 2 times sin square 2x, right? And again this formula is 1 minus 3 by 4 times it is sin square 2x. Now students, just now we have done a problem basing on sin square x. Whether it is sin square x or sin square 2x, whatever here, multiple angle also, for all x belonging to R, the range of sine square function is from 0 to 1. So 0 less than or equal to sine square 2x. It is less than or equal to how much? 1. This is the condition, common condition for all these three problems, and it holds good for all x belonging to R. Every time before writing range of any particular function, don't ignore about the domain of that particular function. So now I took here, this is the value which is in between 0 and 1. Let us come one by one. Suppose this is our required thing. Then I have to make use of this result. Then how much we need to multiply here? By minus 1 by 4. A negative value. Just now we have discussed. So negative value you are multiplying. Therefore change inequality. The 0 is greater than or equal to minus 1 by 4 sine square 2x. It is greater than or equal to how much? Minus 1 by 4. Understand, students? So you multiplied by how much here? This value multiplied by minus 1 by 4. That is the first step. And after that, what value is there? 1 is there. That means you need to add 1. Then it is 1 greater than or equal to 1 minus 1 by 4 sine square 2x, and it is greater than or equal to 1 minus 1 by 4. And what is 1 minus 1 by 4 value? It is nothing but 3 by 4. Now I am just reversing. So students, this is the value we got here by adding 1. Now just here simplify. This is 1 greater than or equal to 1 minus 1 by 4 sine square 2x, and this is greater than or equal to how much? 3 by 4. Now let us reverse the values. If you reverse, what will happen here? It is nothing but 3 by 4 less than or equal to. What about here? This value you got. It is nothing but our function, that is sine square x plus cos to the power of 4x. Therefore students, simply you substitute the value here. That implies 3 by 4 less than or equal to how much we got here? It is sine square x plus cos to the power of 4x, and it is less than or equal to how much you got? The value 1. Understand? So now here we got, this is the value. First one, sine square x plus cos power 4x. You know the value as 1 minus sine square cos square, and then we multiplied divided by with this value, and after that you got 1 minus 1 by 4 sine square 2x, right? And now 0 less than or equal to sine square 2x less than or equal to 1 you got, and as the required term is minus 1 by 4 here, we multiplied by minus 1 by 4, and after that just reverse the inequality or add here 1. Therefore you got 3 by 4 to till where here students? It is 1. And moreover you know about here sine square x plus cos power 4x is same as which other value here? It is nothing but cos square x plus sine to the power of 4x also. Therefore this value is in between what here? 3 by 4 and 1. Hence students, just by knowing here the range of sine square 2x, you are able to write here the other values also. In the same way, if you proceed for sine power 4x plus cos to the power of 4x, then what about that particular value? Sine power 4 plus cos power 4, if I write, this is our value, because what is sine power 4 plus cos power 4? It is 1 minus 2 times sine square x into cos square x. Then here it is just sufficient to multiply divide by 2, and thereby you got how much here? It is 1 minus 1 by 2 times sine square 2x. And thereby students you got this kind of value. Now multiply by how much here? Minus 1 by 2, and thereby this is 0 greater than or equal to minus 1 by 2 times sine square 2x greater than or equal to how much here? Minus 1 by 2. And then add how much here? 1. Then it is 1 greater than or equal to 1 minus 1 by 2 sine square 2x greater than or equal to 1 minus 1 by 2, it is 1 by 2. Hence you got 1 by 2 less than or equal to this entire value. It is nothing but what here? Sine power 4x plus cos power 4x less than or equal to 1. Therefore the minimum value is 1 by 2 and maximum value is how much here? 1. In this way you can find even for sine power 6 plus cos to the power of 6 also. What is that particular value here? Again in the same way we start with this one, because all are here having sine square 2x. And what is that particular formula for sin power 6 plus cos power 6? You know, it is 1 minus 3 times sin square cos square, and thereby we multiplied divided by here 4, and that means this is our value, that is nothing but sin square 2x. So 1 minus 3 by 4 sin square 2x you got, and in the same way if you proceed students, you can obtain here range of this particular function. So like this students, not necessary every time you have to go for particular formula, and using simple values you can find here range of big functions also. And next other one also let us see here, that is earlier in multiple and submultiple angles we have proved the results, that is sin x and into sin alpha minus x into sin alpha plus x, or suppose 60 minus x and into sin 60 plus x. You know very well what about this answer you got. This answer is nothing but how much here, 1 by 4 times sin 3x. And here of course 60 can be replaced by 120 degrees. Next value it is how much, 240 degrees or 300 degrees also. Therefore if entire product is 1 by 4 times sin 3x, students clearly you know for all x belonging to R here, you know clearly minus 1 less than or equal to sin x less than or equal to 1. In the same way for all x belongs to R, you can say clearly even 3x also. Okay, nothing to worry about that one, because sin 3x or sin x whatever, the range is in between minus 1 to 1. And next one here, this is our particular value. The answer is how much here, 1 by 4 times sin 3x. Therefore I am converting this inequality in terms of this one. That means what we have understand here from these results as well as from this one, actually you have to search actually the known range terms. What is the known range here for sin 3x? It is in between minus 1 and plus 1. Now just multiply by 1 by 4. So minus 1 by 4 less than or equal to 1 by 4 times sin 3x. It is less than or equal to 1 by 4. Got it? Therefore what is range of this entire function? It is nothing but closed interval minus 1 by 4 comma it is 1 by 4. Okay, so in this way just by making use of our known values you can write. But if you don't know about this answer, understand, suppose they ask you about here what is range of this particular function. Just by observing this you may think about here only sine range is in between minus 1 and 1, what about the other, like that. But here you must make use of our previous concepts. In the same way cos x into cos of alpha minus x into cos of alpha plus x, where that alpha can be 60 or 120 or 240 and 300. So for this also same kind, that means for these two actually the range is nothing but what here, minus 1 by 4 comma 1 by 4. That means the least value is minus 1 by 4, whereas the greatest value is 1 by 4 here. Next one, suppose students if they ask you about problems again based on some other function, that is suppose cos power 4x minus sin to the power of 4x if it is given. Understand, for plus symbol you know the formula. Understand, whenever here plus symbol you know clearly the formula, whereas here minus symbol means what we have to write is, it is cos square minus sin square into cos square plus sin square. Our algebra formula, a square minus b square into a square plus b square. And this is of course all of you aware of this, our formula cos 2x, and this is our 1. And then what about the range here? It is cos 2x. For all x belongs to R, the range is again minus 1 less than or equal to cos 2x less than or equal to 1. Hence what is the range of this entire function? It is again in between minus 1 to 1. Like this here, whatever formula we derived in multiple submultiple angles or compound angles etc., we are going to make use all those in this chapter also, right? So students, till now we have observed whenever you know about sin x range or cos range etc., and next one sin square x range or cos square x range, whatever the multiple angle, whether it is x or 2x or 3x, you can find here range, right? And suppose if I ask you about what about here sin x plus cos x range, got it? Sin x plus cos x. And you should again know about the formula which we derived in compound angle chapter. If I multiply divide by root 2, suppose it is 1 by root 2 times sin x and plus 1 by root 2 times how much it is cos x, right? And thereby this value is nothing but root 2 into sin x, it is cos pi by 4 plus cos x sin pi by 4, right? And even you can make use of both sin and both cos also. Anyways we can write. Now if I write in this way, this is root 2 sin of how much this value? X plus pi by 4. Okay, every time you can't go to flashback like that, don't do that one. Just remember this kind of formulae. So this is the value root 2 times sin of x plus pi by 4. Therefore, what is range of this particular function? Again, I want to make use of this known value, that is sin. For all x belonging to R here, domain is clearly all the real numbers. It is nothing but minus 1 less than or equal to sin of x plus pi by 4 less than or equal to how much it is 1, right? Because this is our known range value sin. Don't observe about these values as long as domain is real numbers. If domain is some other, then you can observe here what about the other values. But here domain is real number, nothing to worry about that particular value. So here it is minus 1 to 1, however this value is given. Next one, it is multiplied by root 2. Therefore it is minus root 2 less than or equal to root 2 times sin of the entire value less than or equal to how much here? Root 2. So students, what is here finally the range of this particular function? It is nothing but minus root 2 comma root 2. In the same way, suppose if I give minus symbol, understand, same way you can proceed even here, minus symbol or plus symbol. But suppose if I give the problem as 5 sin x plus 2 cos x, understand, in this way if I give, then you cannot do in this process, understand, you have to go for some other process. So there we can derive one formula, and using that actually you can find all that values that we can see here next session, right?